So this is another integration techniques we can use for the numerical integrations. This is called the Simpson's rules, or some words we call Simpson 1-3 rules. So this is slightly different on what we did on the trapezoidal rules, because this one we are using the quadratic polynomial to do the estimations. So this is the quadratic polynomial that we're going to do for the approximation for your fx. You just replace this one, you get this. And from this, I can just simplify with this one. This is somehow like the formula based on the trapezoidal rules. And because of that, I can just divide this one for the number n numbers of the strips here. I will get this one. And this is slightly different on what we learned on the trapezoidal rules. So basically, we are not longer starting from x0 to x1, but we jump to x2. So take the x0 until x2 as a single strip here, and do the following for x2 until x4. Mean that for each of the strips here, we're doing for the extra here. And based on this, I can do further the simplifications. So for this one, for each of these integral, I can use the Simpson's 1-3 formulas. Just according to this first integral, I will get this form. The second integral, I get this one. The same thing until you get for the n terms here. And because of this, you can do some simplification, of course. Yes. And you try to look at here. So for every term here, you have the h over 3, h over 3, and h over 3. So at the end, you can just simplify. You can just take out the h over 3 outside. But you notice that the first point and the last point, they don't have any repeated point in between here. So that's why the first point and the last point will be the 1. I just take out in here. And then next, I try to take a look on the f1, and then the f3, and then about the next term maybe it will be the f5, and so on. So that's why I noticed that there will be something like the odd numbers of the f here. So I will grouping here the odd numbers, and then with the coefficient 4 multiplication, because this is the 4 f1, 4 f3. So this is 4 f3, and then you have later you have the f5, and so on. And then the rest of the point, like the f2, the even numbers, the even number f here, the f2, f3, and then the last one may be f6, f until the fn minus 2. So this is the even number. So this is a formula for Simpson composite rule, and you're using this one normally for the integration.